thank you very much that you find your way to CEF during the lunch break. And I still hope that you can get something to eat after this very fascinating lecture we will have the chance to listen to. So my name is Zita Sebesvari. I am heading one of the sections at UNU-EHS, and it is my great pleasure to welcome today two guest speakers. We invited on a very short notice, so extra thanks to you that you could make time for this event on such a short notice. So Mike Beck, to start with, I know him since 2012 when he came to UNU as a few Marine visiting fellow and spent some months with us together with Fabrice, where we were thinking about how we could better align joint objectives in conservation and in disaster risk reduction, and this is where our collaboration started, and since then we met on very different occasions. Just to give you a flavor about his role as a marine scientist in coastal research in relation to ecosystem-based measures, when you have a chance to look at the ESROC report, the IPCC special report on the ocean and the cryosphere, and you look at the measures related to ecosystem-based approaches, the review is actually starting today, you will find that Mike and his work features there very strongly. So that's probably also an indication of the very large footprint he's actually having in this coastal ecosystem-based defense. And what is really interesting about the lecture today, that it nicely combines the science, practice, and also the financial aspects. And this way I would like to welcome very warmly Kerstin Pfliegner, who is the director of the TNC here in Germany. And so he's coming into this study with risk transfer options, so how to use ecosystem-based measures also from the insurance perspective. And I think this is a very new and very exciting challenge, and I am really looking forward to listen to it. Kerstin was before with WWF, so he has a very strong track record also in water-related issues in Africa, worked before us at UNDP, so very warm welcome to you, Kerstin. So I learned from our presenters that Mike will start and then Kerstin will follow up. And then we will have plenty of time to question and answer, so keep your questions, and we will have around 20-25 minutes for your questions and a joint discussion, so the boss will not run away and will stay with you to answer those questions. So very warm welcome.
All right. Thanks, Zita. It's an enormous pleasure to be back here. As Zita said, a lot of this work for me started in 2012 when I was a visiting fellow here. Fabrice was my host. It's wonderful to be able to see you back here as well. This was such an influential period for me, being here at UNU and working together with the collaborators. So it's really terrific to be back, and the weather's a lot nicer than when you hosted me here, so it's actually very pleasant today to be back. As Zita said, what Kerstin and I are going to talk about is the role of natural coastal defenses. We all know that risks are rising on our coastlines, and that decision makers are seeking effective and cost-effective solutions. And nature can be a part of those solutions. But in order for it to be a part of those solutions, we've got to be able to rigorously quantify those benefits and be able to show when, where, and how they're effective so that we can direct more resources to their conservation and restoration. I'm glad to say that I really think we do have and are establishing that kind of rigor, and I hope that we'll be able to demonstrate that to you today. As you said, I'll cover a great deal of science, and then Kerstin will cover some of what we're doing in some of the practical application of that. I also want to recognize, so that's obviously not Kerstin over in the lower right. Also, another colleague that I spent a lot of time with on my Pew Fellowship was Inigo Losada at IH Cantabria, who's here. He's a professor in engineering, and you know, our collaboration together on this work has also been enormously influential, and his work is you know, essentially now completely intertwined with most of the things that we and our groups do. Okay, this figure here explains a lot of why we're interested in understanding the role of natural defenses. So we did a review last year looking at funding that was directed into like what we would say is natural or green infrastructure, and compared that as to funding going into more gray infrastructure like seawalls and the like. And what you see here on the left is you know, what we were finding for coastal investments in coastal green infrastructure, a few billions of dollars over a 10-year period. When we looked at a variety of sources, from international aid to insurance and government payouts after storms, most of which is going into gray solutions, we were finding much, much greater investment in those kinds of solutions. I mean, the conservation community talks all the time about, wouldn't it be amazing if we could double the conservation budget? And indeed, it would be amazing if we could double the conservation budget. But that's still nothing compared to changing some of how our other funds are spent on our coastlines. And the bulk of this talk is devoted to how can we begin to change the way how we invest in our coast, changing our coastal investment portfolio. We just released a new report on the role of mangroves in risk reduction on Wednesday here in Berlin. So I'm going to talk a little bit about this to start, but then we'll loop in coral reefs and some other wetlands as well. You can find summaries of the report here on the side table and at the link here. And what we're talking about throughout the discussion today is the role of these habitats in reducing waves and storm surge. So as we lose these habitats, then we get increasing waves, increasing flooding, increasing impacts to people and property on our coastline. And we need to understand just how extensive those impacts are and when we can reduce them. So in 2016, we worked with the World Bank to develop guidelines for valuing the coastal protection services of coral reefs and mangroves. It's a substantial report, 170 pages. I'm going to summarize it in one slide for you. You can thank me later. And what it comes down to is a recommended approach for how we value these benefits. And it involves sort of 5 core stages. You need to know something about waves and the wave environment and water levels offshore. You need to understand how they change as they get near shore. You need to understand the effects of habitats on those waves and storm surge. Then be able to estimate flooding and do that across the entire storm frequency distribution. Your 1 in 10 year, your 1 in 25 year, your 1 in 50 year storm, to be able to assess the damages. And so this gives an example for the flooding level for a 1 in 10 year storm with habitats in place. And then we do another modeling effort, imagining that you have lost that habitat, asking what the new flooding line would look like using hydrodynamic and economic models. And then all of the people and property between these 2 lines essentially represent the people and property being protected by those habitats, the value of keeping those habitats in place. So this is the core of a lot of what you're going to see in the next few slides. Again, this looks very simple. It is not very simple. It involves quite a number of data sets and hydrodynamic models, and then economic models to understand what's the role of these habitats in reducing exposure to people and property. Okay, so for the work on global mangroves, we put together these hydrodynamic models, and this gives you some idea of the scale at which we do this modeling all of the mangroves of the world. So there's over 130,000 hectares of mangroves around the world. Actually, that figure's low. Sorry, I need to get that right figure. But at any rate, it's in 161 countries. And this shows the flooding with mangroves. So these are mangroves here. This is one bay in the Philippines. This is with mangroves in place. This shows the flooding, not just the flooding extent, but also the flood height in order to be able to estimate the damages. And then we imagine removing those habitats, asking what those new flooding levels are, and we're doing this in 100-meter grids all around the globe, and then looking at the changes in both the distribution of flooding and the flood depth to be able to estimate the impacts and damages. This global flood modeling represents advances over all other global flood models, not just dealing with habitat, all coastal global flooding models. We've downscaled them to a 90-meter resolution, again, 100 by 100 meter grids. We're using hydraulic connectivity, not bathtub flooding of your coastlines. We're using 30 years of wave, surge, tide data to be able to reconstruct the entire flood height time series in each one of these locations around the world, with country-specific adjustments to GDP per capita, additions of near-shore bathymetry, which is actually the most limiting data set of all right now, and then, of course, adding ecosystems, which hasn't been a part of other global flooding models. There are still major constraints. I mean, in order to do this globally, you have to look at flooding as a 1D process, and it's difficult, even though we're doing this at a quite fine resolution, representing some of the smallest islands well. Okay, so that gives a bit of background about how we arrive at these results. And so what we're looking at here is the property flooded with and without mangroves across the entire storm frequency distribution, again, 1 in 25 year up to 100 years, 100-year storm. Looking at the field property flooded, this case property flooded with mangroves and then without mangroves. And the difference in value in these lines represents the benefits of keeping those mangroves in place. And if you integrate the area between these two curves, you get the annual expected benefit. And that's really important from, for example, a national accounting standpoint. What's the value of these habitats every year? This represents a 16% difference in flooding impacts if we were to globally, if we were to lose mangroves. And for people, it's even worse. 39% more people would be flooded annually if we were to lose those mangroves. And this sort of summarizes these differences globally with and without mangroves. So we're talking on an annual basis about 18 million more people flooded and about 82 billion in capital damage, property damages without mangroves. So they're offering really significant benefits. And again, it's not just that we can put together these values globally. The really important aspect of this is that we can identify the spatial variation in where mangroves matter the most. And this is really important in being able to develop and devise solutions and identifying where we should put those solutions in place. So this is just one of the global maps. And again, each of these bars represents the annual expected benefits, the annual flood reduction benefits by keeping mangroves in place. So the higher the bar, the more important mangroves are in those geographies. And again, we can put very specific dollar values on those benefits. I should also say, sort of along the way here, you should feel free to stop us if you have questions along the way. We'll have plenty of time for discussion, but if something you don't get along the way here, feel free to stop me. Okay, and then not only being able to show the spatial variation, but then being able to identify and rank the countries and value the benefits of mangroves to those countries. And again, you can look at those values in terms of people protected, and then you get kind of this ranking: Vietnam, India, Bangladesh, where mangroves are incredibly important for reducing flooding to people. You can look at where they're particularly important for protecting property. Again, in this regard, it's almost a surprise to some folks in the U.S. The U.S. actually is a very tropical nation in many of its aspects. And so when we lose mangroves and coral reefs, there are actually very significant repercussions in terms of budgets. It's also important not just to look at these values in the absolute sense, that is how many people, how much property is protected, but to also think about that either per capita or per GDP. In this regard, many nations in Africa, a number of small island developing states are highlighted. These are the countries that receive significant impacts from storms, but often don't have the resources to recover for those. So in many respects, losing mangroves or reefs in these countries has even more significant impacts with regards to storms and flooding. The one other thing that we did with this information is to put together not just exposure and flood exposure. So right up to now, I've kind of talked about what's the role of mangroves in reducing the flooding extents and the flooding heights. But working with our colleagues at the Alliance Development Works and with the World Risk Index, again, something that I was introduced here to, and working with my UNU colleagues, we put together not just the exposure reduction, but then try to think about, well, what does it also mean? What are the mangrove benefits in terms of vulnerability reduction to people's lives and livelihoods? And can we identify where mangroves are particularly important, not just for reducing exposure, but also vulnerability? In this regard, you see many more African nations, for example, highlighted as receiving some of the most significant benefits overall in reducing risk. And this just shows the top 10 list. And again, we can rank all countries of the world, provide values, annual expected benefits for each one of those countries. Again, kinds of figures that can get included in national accounting, among other things. We've not just done this work globally, you know, and I was talking about one-dimensional models when we do that. We also have drilled down into countries like the Philippines, where mangroves are particularly important, and we can do even more refined hydrodynamic and economic modeling to understand the benefits of mangroves. And sometimes there's also information on historical distributions, which gives you some idea of where mangroves could be restored. So in this case, we're not only examining the difference, in this case, in property flooded across the storm frequency distribution with and without mangroves, we can also examine how many more benefits have been lost relative to the historical distribution of mangroves across the country, and then identify where, for example, some of those benefits might be greatest to people, or property, in this case people, if we were to restore those mangroves. So again, not just looking at what the losses might be if we lose more of those mangroves, but also helping to do, for example, municipal planning so that we can identify where to direct those restoration efforts for maximum impact. I will only really briefly say that out in a few weeks will be a similar set of results for the coral reefs of the world. So we've also done the entire evaluation. Everything that I just showed you for mangroves, we've done for coral reefs, and that'll be published in Nature Communications in the coming weeks. Yes?
I have a question, because so far you have shown the benefits, but I wonder if you will show maybe later on the cost of maintaining those coral reefs or mangroves?
So in this particular talk, I won't talk a lot about cost per se, but we can, how about we cover it more in the discussions when we get into some of the tools and how we could use some of those financial tools to invest in restoration. We've actually done a lot of the cost estimates, so I can provide some of those. Okay, so up to this point, you know, we've taken a look at what's the value of these habitats. We've done that with these engineering models. But one of the things that we wanted to do is to say, well, a lot of times folks say, well, that's just the scientists and the conservation groups doing those estimates. We wanted to work directly with the insurance industry and risk modelers to ask, what do their models say about the role of habitats? Because it's one thing if I tell you that habitat matters, it's another thing if those businesses say, actually it turns out our models also say they matter. We want to test that. I've done this work with colleagues Carter Ingram and Sid Narayan, who've been central to many aspects of this work that was supported by the Lloyd's Centenary Research Foundation. And there we asked, initially we went to the industry and we said, one of their brokers said, you ought to ask them, what do their models say about that? We asked the folks at Risk Management Solutions, which is one of the top 2 risk modeling firms in the world, and their answer was, I don't know. They didn't know how habitat was represented in their models, how well it was represented. It turns out, actually, it was programmed in early in their model development. They actually represented it relatively well, but none of their clients had ever asked them to value the benefit of those habitats. So what we did, what we started with was asking during Hurricane Sandy, so Hurricane Sandy had devastating impacts throughout the Caribbean almost 6 years ago, but then also in the Northeast U.S. This is the hurricane track here, eventually coming over New Jersey, having greatest impacts there. In the green is the remaining coastal wetlands, which are marshes in the Northeast U.S. And we basically asked in RMS's loss models, what would have been the impacts from Sandy if those habitats weren't there? So this is with the habitats in place. This is imagining those habitats becoming open water, and then we examine in the model what those benefits say. Let me see if this plays. Whoops. I'm not sure I'm going to be able to get it to play. Okay, not to worry. At any rate, they have an extremely rigorous flooding model, and you can see the kind of dynamics of how that flooding happens along the coastline. They're extremely good at this work. But what we found in a nutshell was that marshes have really significant impacts in damage reduction during Hurricane Sandy. Overall, $625 million. There would have been that much more damage without those marshes in place. Importantly, not just in those major storms, but when we looked on average at what those benefits of mangroves were, there was on average a 15% annual reduction in damages owing to those marshes. That's actually at the level at which you would get premium adjustments. So the kinds of things that the insurance on your home, for example, if you were improving the roof or something like that, if you were doing things that resulted in a 15% average reduction in losses, you could reasonably expect to get premium reductions for that. So those are pretty significant impacts from the insurance industry's perspective. Again, just because I didn't note this before, so these are the percent reductions, so you can really identify areas where marshes were particularly important. This has to do in part with the distribution of marshes. So for example, there are not many marshes remaining in New York and Connecticut, but it also has to do with where the storm came across as well. One of the things that I found incredibly interesting, that because their models are so rigorous, that we were able to look at was these are the marshes, these are the percent damage reductions, the redder is a greater percent damage reduction. In this case, because a lot of analyses when they do this, they go, well, what's the amount of marshes in a given, say, county, and then what's the average damage reduction? And sometimes they don't find correlations. This is one of those places where you actually understand why that might happen. This township, Hamilton Township, has very little marsh in its borders. but it received really significant benefits from marshes in terms of flood reduction because of all the conservation in the townships downstream. So they're receiving all the benefits from the conservation of others, and so it's really important to be able to understand those essentially watershed-based influences. This kind of work has then influenced where and what kind of restoration we're involved in. This is a project with the Army Corps of Engineers. It uses beneficial use of dredge spoil. So essentially we're helping to build up the marsh with thin spreading of sediments using the dredge sediments that otherwise the Corps was going to have to dump offshore. There's a lot to figuring out how to do this right, so that's a very simple thing to say, but this is one of the ways that we're working together to be able to apply this kind of knowledge. Okay, so up to now, I've shown, okay, we can really value the benefits of these habitats. We can show that that's not just in the scientific models, it's in the business models as well. We then ask, it's not just about effectiveness, it's also about cost effectiveness. So what are the benefits relative to how much it's going to cost to put those in place? And I actually forgot that I included the cost effectiveness part in this talk. Okay, so we'll cover that a little more directly now. We worked with Swiss Re to do this work. David Bresch was their chief of sustainability. He's now at ETH Zurich, led by Dr. Borja Reguero, part of this work. And what we did was ask, what's the relative cost effectiveness of nature-based versus gray, seawalls, dikes, and the other. There are three major parts of that model, kind of essentially building on what I was just showing before. You have to be able to estimate the hazards, wind, rain, storm surge. You have to estimate the damages, and then you go look at what your adaptation options are, the cost-benefit functions. We did this across the entire Gulf of Mexico in all of essentially the census blocks or zip code units throughout the Gulf. So we're looking at really large-scale both impacts as well as actions. First thing you have to ask is, well, what are the damages relative to this? So if we look at what are the storm damages in 2010, there's about $170 billion worth of damages expected on an annual basis. We then ask both, what were the effects of economic growth? In this case, what we're calling high economic growth, but really that's just 3% growth overall. Comparing that to the impacts of climate change, and then estimating what those impacts are by 2030. The most important part of this analysis for me was remembering that it's not just climate change that's increasing our risks on these coastlines. In fact, over the next 10, 15, even 20 years, a lot of what's causing increases in risk are the development choices that we're making locally. We sometimes forget that in all the work that we're doing on climate change and climate adaptation and thinking about it as a global problem, which we must do. But a lot of this is local issues, and we can't forget about that. And that's actually when the insurers go, yeah, climate change is kind of important. They're not saying they're trying to get out of the understanding the impacts of climate change. They're often saying, yeah, but this is what's really driving the risk that they care the most about. Okay, so then we wanted to be able to assess and compare a variety of adaptation options, as I said, across the entire Gulf of Mexico. These are some of those that we're comparing: wetland restoration, conservation against levees, sandbags, local flood walls, and we're talking about really large-scale solutions that we were talking about implementing, hundreds of miles of coastal restoration, just by way of example. I'm going to sum up again, a lot of work in one graphic here. And what this is comparing, that got cut off. So this is the benefit to cost ratio. This is the averted damages from the different measures: sandbags, wetland restoration, oyster restoration. So the higher the benefit to cost ratio, the more cost effective those strategies are. So in this case, actually, sandbags are quite cost effective strategy. They're actually quite cheap to implement. You know, you can avert damages up to whatever height you can stack those sandbags, and you can do that relatively efficiently. But then, most of these other measures that were particularly cost effective were the ecosystem-based measures. Much cheaper, much more cost effective than, say, adding in local levees or home elevation or a variety of other strategies. So in short, what we were saying is that nature-based solutions can be a really cost-effective part of the suite of solutions for reducing the total amount of damages that we expect by 2030. And again, for us and for the work that we do, for example, with the Army Corps of Engineers, being able to show that you can compare these things together using the same tools and models is incredibly important. It's not holding ecosystems and ecosystem service models out as something separate. It's doing them directly within those industry-based models. I also want to note, and we're going to start to talk a little bit more here about, you know, what does that mean in terms of implementation. You know, so we've been using these tools and knowledge to be able to design reef restoration. For example, in Grenada, they're facing really significant effects from erosion. Then we've been working with the local communities there, designing a reef restoration solution. With Borja, we just recently published some of both how we evaluated the impacts of reef loss and then how we designed a reef restoration solution to address those impacts. This is Granville in Grenada, the second largest city in Grenada. They've been facing really significant erosion and wave impacts here. We showed that that was largely explained by the loss of corals on the northern lobe of the coral reef. They were keeping their southern lobe in place better, and they weren't getting impacts on this shoreline. So we showed that loss in the height of corals on this northern shoreline was this northern lobe of the reef was impacting erosion flooding. And then we designed a reef restoration solution to reduce those impacts. And again, working with the local community, putting that in place, and you can begin to see some of those benefits right away. Okay, and with this, I'm now going to pass to my colleague, Kerstin.
So before I continue with the slide deck, I would like to say a couple of years ago, maybe about 10 years back now, I represented the German Federal Environment Agency in an expert group at the OECD on climate adaptation. And in these expert group meetings, we were talking about green measures versus grey measures and how they would help with adaptation. And that's around the time when the entire ecosystem adaptation debate was born, the EBA debate. And so some insurers were already in the room, and FEMA was in the room, but really we didn't have the data to rigorously assess the risk reduction effect of these natural ecosystems, and also we didn't have cost-benefit evaluations to really compare the so-called green infrastructure measures against grey. So time has passed, you know, I've been in Africa in the meanwhile back doing implementation of adaptation projects in the field, and so I joined the Nature Conservancy 2 years ago, and I came across this body of science that Mike and his group have worked on. So I was really fascinated by this work. I think it's cutting-edge science, and I have made it a priority to help with TNC carry this work into practice. And so I found already, you know, a broad-based insurance program in TNC. So Mike told you about some joint science with Lloyd, so a lot of this research has already been conducted together with the industry. So TNC was then quite ready to have a first field implementation of a reef insurance, and was the first kind of reef insurance that was ever implemented worldwide in Mexico, in Quintana Roo. And so you can see here on this side that this is an area of the world where you have hotels and properties built up really on the coastline, on the shore, and you have the Mesoamerican reef in front of that beach lounge protects those properties against storm surge. So TNC, because we had this body of science, reached out to Swiss Re, and Swiss Re was very interested in this data, and together in a partnership we were able to design this reef insurance. This insurance is actually a parametric insurance which insures the reef for damage once it has occurred. So if a storm hits the reef, with the insurance payout, the reef can be repaired. So then we thought, what if we could design, how do I do this? Yeah. What if we can design an insurance solution together with the private sector where we actually build resilience upfront? So in a partnership with German UNU-EHS, we sat together in a joint team. And so what you see on this slide here, that was the question we asked ourselves. Very often the risk owner, be it a vulnerable country or a group of hotels, they have a trade-off between, how do I use this point? So there's a trade-off between risk transfer, meaning an insurance solution, and building up resilience, which leads to risk reduction, because very often we're dealing with highly indebted countries which have very little fiscal space to actually do both. And so we thought, what if we could overcome this trade-off and combine both in one solution and develop a concept or a product where we invest in a resilience building measure upfront and have an insurance payout in case a storm surge or disaster strikes. So, and this is the concept that we have developed jointly with UNU-EHS. It's, we're calling it resilience insurance. And the whole idea builds on a resilience, so-called resilience dividend. So you see here in this yellow bar, there's a resilience investment upfront. So this could be, for example, the rehabilitation of a coral reef or restoration of a stretch of mangrove forest. So that's what we're starting with. And then because through the data that Mike has shown, we were able to really reliably show how these ecosystems can reduce risk, UNU-EHS said, okay, we can price this now in our insurance premium and price in a risk reduction effect, which leads to a lower premium payment. And then you can see here, because through the risk reduction effect, you amortize basically your initial investment. And then 5 years later, let's assume we have a storm that hits. Hopefully the effects will be lower because we have the healthy reef or the healthy mangrove forest. And still, there's disaster risk payout, so vulnerable communities or critical public infrastructure can still be restored. So this combines both the resilience investment and the risk transfer solution. I just wanted to show that very quickly to the insurance experts here in the room. So we know that in insurance talk and insurance mathematics, the so-called expected loss and the risk premium are positively correlated. So if your expected loss is higher, your insurance premium is also higher. Your insurance is more expensive. But if you can reduce your risk, then also your premium, your risk premium can be lowered. Think, for example, about maybe a house insurance or a fire insurance for your house, a home. If you, let's say you establish a sprinkler in your house, then you can probably, purchase that insurance at a lower price. So that's the same principle here. And this is the so-called variable reset in the insurance industry. So for a resilience concept like this to work, we need a couple of enabling criteria. For once, we need the habitat to be placed, to be restorable. So this is what Mike just spoke about. We also need exposure to a hazard. So we need high enough storm surge risk so that it is insurable. But then also, not to forget, we really need the right political framework. So we need a country who is willing to acquire an insurance to insure the vulnerable people, or to insure the public infrastructure, or maybe a hotel association who feels sufficiently high risk to acquire an insurance like that. So some of the recommendations of our work so far, together with the insurance industry and also with governments that we're working with, and results of our science are, we have rigorously assessed the risk reduction effect of a number of ecosystems, mangroves, coral reefs. Mike has shown the work on wetlands, and you have seen even oysters were mentioned, so even oyster reefs can reduce risk. So for all these ecosystems, we should scale up the restoration efforts so that we can reduce the risk reduction, increase the risk reduction. In order for these concepts to work, we need support from development banks and also climate aid funders. And we're not talking about an insurance subsidy here per se, because we want to work towards really marketable, replicable products. But a lot of these upfront investments don't amortize the entire amount. So in all of our calculations, we have actually built in partly subsidies from development banks. And we're in discussions with KfW and also the World Bank. Then these solutions that Mike has presented actually can be included in national adaptation plans of action. They can be included in land use planning. Just to give you one example, we had a discussion with the government of Fiji last year during the COP, and when they listened to Mike's presentation on mangroves, they said, if we would have known this before, we would have never allowed the hotels to cut down all the mangroves at our beachfronts. We would have tried to integrate that into our land use planning concept. So it's also raising awareness and then using this data for land use planning and also risk management planning. So we now have valid cost-benefit analysis for coastal defenses, so we can actually compare grey versus green infrastructure. And this kind of data also allows integration and system of national accounts. Actually, TNC has piloted that jointly with the World Bank in the Philippines. We have now the data that allows the insurers and also reinsurers to include it in their risk modeling and offer premium reductions like I've shown in that example. And we can also develop new financial tools that support the restoration of risk reduction. I just wanted to point out, and it's my last slide, that all this work actually fits very nicely in the current policy framework, sustainable development goals. Many of you are familiar with target 40.2, which points out to coastal and ecosystem restoration to strengthen resilience. Then we have the 4 priorities under the Sendai framework for disaster risk reduction listed there. And yesterday's SUVA dialogue under the loss and damage debate also I heard discussed about mangroves. The risk reduction effect of mangroves was discussed there. And then if you look back at last year's G20 summit in Hamburg under Germany's presidency, the topic of disaster risk finance and insurance solutions and resilience featured very highly there. And subsequently to that, the Global Industry Resilience Partnership was formed to which we as TNC have also become a member, and we hope that we can contribute with our science and practical experience to the dialogue there. Thank you very much.
Thank you very much. I think this is a good time because we have probably the highest number of audience to say also thank you to Sef, personally to Lisa Freidenberger, and also to Alma, so that co-organizing with us the event and hosting us. Thank you very much. And with this, I would like to open the discussion. Thank you for being available for questions. Who's coming first?
Thanks very much for the presentation. Very nice. Bringing it to the point of how much green solution can be cost effective or not. I was wondering two things. One is a clarification question, and the other one is maybe outreach related. First, maybe how much of the subsidies that you calculated from development banks or have to be, what part of that whole proportion is that compared to the amelioration and overall investment?
Well, I'll start. I mean, the short answer is it depends, and that's only just because if you're looking at places where reefs offer much greater risk reduction benefits and are cheaper to implement, or you're looking at habitats that are cheaper to implement. Sometimes mangrove restoration is cheaper than reef restoration. All of those are going to eventually affect the calculation. And we're able, because of the partnership with Munich, we sit down and look at every geography and essentially pencil it out based on all of that to go, is this actually going to work or not? And how much are we going to have to raise additionally, if anything, to make it work?
Yeah, no, I would support that. So each case is really different. We have now calculated some more detailed case studies, one for Fiji and one for Indonesia, and one for coral scenario and one for mangrove scenario. So the figures are different in each scenario. In general, coral reef restoration is slightly more expensive than mangrove restoration. So if there was a subsidy on the grant side, it would probably be slightly lower for the mangrove case. But it really, as Mike has said, depends on each situation. But we have the Fiji case for corals. We assumed a 20% investment from a development bank.
And I want to say, because I don't want to just get away with the scientific answer of, oh, it depends. It depends, and we can answer it. So it's not just it depends, and we don't know how to answer it. We know how to answer it together. And
so in that case, we calculated for Fiji the reef, the insurance premium reduction took basically amortized 2/3 of the entire cost, and about 1/3 needed to be subsidized, which even Munich Reef said it's a very good cost-benefit scenario.
Okay, then we can skip the second part of the question.
Okay, in your cost-benefit analysis, you only talking about the benefits in relation to the coastal protection, but that's much higher. The value of the I mean, you have all the other benefits for fisheries, biodiversity, etc. So, okay.
So a short answer there as well. So we did actually look at the additions of some of those co-benefits. But it's also true that if you're offering a solution that provides property damage reduction, those benefits are so much higher than the additional fishery benefits or this. Now, that would be different if you were explicitly designing some restoration for fishery benefits, not necessarily near coastal properties or something like that. So the cost-benefit equation is going to change. But where you're offering property damage reduction benefits, they dwarf the other co-benefits most of the time.
And if I may add, I think it's a very interesting question, and we discussed about that a lot. And the solution in the end was that we don't need the co-benefits to be calculated for it to look attractive from the insurance side. So in other words, the risk reduction effect is high enough to make the insurance product attractive. And then the other benefits would be additional co-benefits that would then come on top. But if they were calculated, which is not so easy, then of course the
it's not
benefits
easy, that's true.
that is not so easy. Yeah.
Fabrice?
Yeah, but just to bounce back on that, the co-benefits might be important to the communities, and therefore, in terms of persuading them to restore mangroves, to conserve mangroves, to restore coral reefs, this is perhaps important to computers.
Well, I heard it best from a general in the Army Corps of Engineers. You actually have to get a project like that on the books for the flood reduction benefits, but when you go to sell it, if you're with a group of bird watchers, well, then you're selling the bird watching benefits. If you're with the Run and Gun Club, you're selling the fishing benefits. But you got to get it on the books in many of these cases with the flood reduction benefits.
Also, the co-benefits will differ greatly depending on the location. So for this global analysis, and the concept is based on global data, I think it's difficult to integrate them. And also, I mean, we needed to show cost reduction that we confidently can say they will really materialize, because for TNC to then restore a reef, or whichever partner would do that, we can also guarantee that risk reduction, and we can also estimate the cost, but the core benefits are much wider in terms of responsibility of making sure they actually arise.
Can I take selfishly here one question, because you say guarantee the risk reduction, and this is where my question is: how does this relate to the quality of the ecosystem? Because we are talking about quantity of distribution pattern of mangroves and so on, but how does it also happen on the quality, dependent quality of those mangroves?
It can depend a lot. So one, all of these estimates are probabilistic. So, one, you're just trying to estimate what the expected risk reduction benefits are. But again, that's how all of your insurance premiums and everything else are already set. What are the expected losses based on how good a driving record you have and the like. One, that's important. But then two, if you have, for example, mangroves of greater density, that's going to have greater impacts on flood risk reduction. With reefs, I can say, because we've actually done all the modeling, that what matters most is the height of the reef. So 80% of the benefit is in just how high you can make that natural seawall. After that, the rugosity, the roughness of the reef, which comes from how much living and growing coral you have on it, that's about 20% of the risk reduction benefit. So you really got to get that height back, and then you work on plantings of corals to get really back that living reef.
I think the quality question is also interesting, because once we implement a project like this in the field, then this would be now together with an insurance partner. So that insurance partner will obviously reliably have some risk reduction statement, and how can we assure that? So we need to make sure with some very solid monitoring systems in place, which I would say we're trying anyway in our field projects, but once you have private sector on the table, this will even reinforce the rigorousness of your monitoring once you're in the field. So I would see that also as an additional benefit.
I have seen your hand.
Yes, just out of curiosity, you were mentioning the reef insurance in Mexico, and I wonder if you were offering that insurance, as you mentioned as well, about reinsurance to the government, or is there any other plan to make it make it smaller, to offer it to the hotels, maybe, or to any other organization?
So this is actually the hotels. The hotel chains have purchased that insurance, and the whole financial architecture behind it goes through a local government trust fund. So it is actually, so the risk owners are the hotels and the municipality.
One question. In the beginning, you said it's a lot about awareness raising, and also
Speak up a little bit.
Okay. It's a lot about quantification of what nature-based solutions can pay out in the end if you do the investment. wondering to some extent if now it's already clear to many that nature-based solutions have a lot of benefits, but the implementation is lacking because of other reasons. I was recently in Vietnam. They know exactly that building hotels at their coastal front is causing coastal erosion quite a bit. They try to reduce that in the land use plan, however it's still happening because of economic benefits of the tourism sector. And they are choosing that, I think, because of short-term economic benefits instead of long-term revenues. And so I'm wondering, even if you put numbers on it, is it really helping to have some good practice examples where your numbers convince?
Yeah, well, this could be the topic of a very lengthy discussion. So we'll try to be brief. But a couple things. I mean, one is we should be very clear. I mean, you know, as a person extremely interested in conservation, I hope we're preserving these habitats for their inherent benefit. But you know, so we've talked a lot about money and values in this, you know, because we think it's an important part of the argument. But it only should ever be one part of the argument, one. Two, you know, I actually do think that really providing those values helps you understand how great the loss is. Because a lot of times, I mean, folks will understand there's some connection, but if you can't quantify what the connection is, they still might go, it's there, but it's, you know, it might not be that great, or it might not be that important, or I simply don't know how important it is. You know, so there is, you know, we've been to governments in, for example, Papua New Guinea, and they say, oh, those are great arguments. You know, when before we were really putting the hard values on it, but saying, you know, here's how they work. And yeah, we believe you, but you know, we still know how a seawall works, and so we're still going to invest in that. So it really is a mix of both showing how great those benefits are, getting our private partners to be part of making that case with us and saying, hey, it really matters in your bottom line, and then getting to more of those demonstrations so people actually understand the solutions can work.
So if you remember that slide that I had with the 3 enabling conditions, the political framework is probably now the more tricky part, right? Because the rest we can calculate, but you know, a lot of this is like the example of Fiji I mentioned. So let's assume there would have been some legislation in place that mangroves cannot be cut at those places. That would have happened. But without kind of legislation being in place, the right regulatory framework, the right policy incentives, it may be very difficult to get to where we're hoping we can get. And so all of this is also meant to raise awareness about the importance of these ecosystems to government, you know, to adjust their governance framework around it.
I'm not sure if you mentioned it already, but according to your experience, how long time it takes that the restoration, so in English,
So
takes an account until you have the restoration already, as how long time it takes to be restored, and then the connection with ecosystem services for the local community to give the services and to improve the life standards for people.
Well, it's a really important question because it's actually central to the insurance calculations as well, how quickly you deliver those benefits. Because a very important part of making all of this work is that long-term planning for the insurance industry is 5 years. So something actually has to really work and reduce costs in a much shorter time frame. Now, something like the reef restoration work, you know, if we're willing to do those structural enhancements to raise the height of the reef quickly, those benefits, the risk reduction benefits, can happen virtually immediately and will take longer to develop the conservation benefits. But that's actually really important in the insurance calculation. Mangroves, while cheaper to implement, are going to take a little bit longer, you know, for decent tree growth. You know, so you're probably talking, you know, kind of a minimum of 3 years for some decent benefits, you know, and then those continuing climb over time.
Not that long compared to other trees growing.
Right. I mean, mangroves in the right conditions, mangroves are weed. They have few competitors, you know, so you can expect pretty good growth. Of course, we know that there are lots of conditions where you put the wrong species in the wrong places, you know, and not successful. So you have to get the ecology right.
I have a question to our guest because just a second, because now it's 1:30. Can we go a few minutes longer, or are you rushing away?
We're okay.
Okay, good. Then I have seen Lisa.
No, I was just looking at the other question.
I
Just one
Thank you.
question because he was raising his hand.
okay.
Thank you very much. Thank you also for your very interesting talks and very impressive work. My question relates to whether you factor in future developments of the local communities. So I think there's expected changes in land use or expected population growth or dynamics, because, well, since you try to project the future, this also should be taken into account. And I don't know if you also already do that, or if you try to do that in the future. Yeah.
So some of the new essentially economic growth scenarios, part of the IPCC work, and others are you know, starting to get better estimates of you know, what that kind of growth should look like. That should get incorporated better in models. For the kind of 3% economic growth, we were just assuming essentially increases of values of where the existing footprint was. That's not obviously true. So we want to get better at these kind of calculations. Again, this is one of those things where I'd say a scientific community has spent so much time getting better sea level rise estimates and all of these things. We need to spend a little bit more time thinking about those socioeconomic changes.
I think it was him and then you.
Mine has just, through other questions, been reduced rather to a comment because of the factor of time. Is so important for insurance industries. They calculate revenue all over time, investment, time, output, and likelihood of the event. And if you compare that to the uncertainty we have, that all the factors that you try to factor in, you said there's one slide, but we have reduced it to a lot. I can only imagine how much reduction has happened to bring it to one slide. But I was wondering, just saying more or less the same, how long does it take for an effective mangrove? It depends on scale, and I don't know how many other things, to an effective mangrove or coastal reef to build up, compared to the same scale, how to build a flood wall, a grey solution, and the timeline for which you just roughly estimated in around 3 to 5 years, depending on scale and whatever, and temperature of ocean and all kinds of things. It's actually not so much different. Right? So if you want to build a huge wall that protects, or the green solution, then I was just surprised by that. It might be effective in a certain period of time, and it might be effective for a much longer time, because the maintenance and operation costs for those grey solutions are crazy compared to green solutions, right?
Very, very quickly, a couple things. We actually have to pay attention to the time it takes.
Sure.
You know, part of the reason the partnerships have been so important, we get to see the questions that they demand the answers to, and then we have to try to answer them. You know, that's challenging, and try to answer it relatively simply. You know, kind of within the ranges of variability that they're comfortable with, which are actually fairly high. You know, when you look at the models, but you know, with reefs, we think we can offer those benefits probably pretty quickly. But as a reef restoration community, we're going to have to figure out what practices in reef restoration we're actually comfortable with, because just planting out some corals isn't going to work. You know, we're likely going to have to include structural restoration. That means, you know, putting things on reefs to help bring back the height that we lost. You know, doing that right, not simple. Mangroves in some respects are easier, but they'll also take a little bit longer to develop.
I think we have 2 more questions here and there, and I think then we will close if you agree.
Yeah. Thank you very much for the presentation. My question is on the conservation, that it's such an important presentation. I want to find out if there's any forum online where you can access information about this for areas like my area, for instance, where lands are not owned by the people, let me put it, mangroves are protected areas, supposedly gazetted by the government, but the people feel not compensated for, and so they encroach it. Those who live there enough, they may take simple non-forest materials from these mangroves, but with time, what is happening is outsiders are now taking are now putting of these. So, are there materials online, or is there a forum where you can link up with people home so that they can get information about it?
Well, the main thing that I was so thank you for the question, because it allows me to point to, we have a site, maps.oceanwealth.org, where all of the kinds of spatial results that we're providing are available. You won't be able to see the coral reef results there for a few more weeks, but those kinds of results are available there, and on that coastalresilience.org site, then there's also more information that connects to some of the other parts of the values and how to address the conservation, restoration, management of those mangrove forests.
And the mangroves work, there are 2 online links on the brochure that's distributed. On the back side, you find the link to those reports.
At that site there.
Another one you had.
Ah, okay. I think we're probably covering it.
I think we have one last question.
But more a comment on the comment, because the time frame is important, obviously, and we tend to say green versus grey, but there is hybrid, and that's one way to also bridge that gap for ecosystems to reach full maturity.
Yeah, indeed. Let's also be very clear. We are never suggesting that nature-based solutions are going to answer all of your problems. We never feel that way. It is always going to be a part of the solution space. That includes policy changes. It includes gray solutions. And again, for all the kinds of risks that we're talking about, you make people safer. You don't make them safe. Completely reduce their risks. It's about reducing those, not suddenly getting rid of them.
And often hybrids are probably the best solution.
Thank you very much. I really feel this is a good closure. Thank you very much for coming, and also for your very good questions. And I hope you will enjoy the sunny weather on the weekend in Bonn. Thank you very much.